So we switch now to another
Thank you very much.
presentation. Yulia Veselova will present her recent works. I would like to say a few words about her. Yulia Veselova was my PhD student some years ago. She did her work in a very brilliant way. She works very actively. She's a professor of in our department in Moscow. And today she will tell us about her recent works. Yulia, please, floor is yours.
Thank you very much for the speech. Should I share my screen? I suppose.
Yeah, you should. Yeah, we can see it, but put it into the full screen regime.
Ctrl-L.
Great.
Thank you. Okay. I would like to tell you.
Yulia, we don't hear you very well. Please switch on your microphone or do something. Your voice is very low, you see.
I see that there is the case I see, but I have no choice of microphones, so I need to speak louder.
Yeah, please then speak louder. Not very good. Yeah.
Yes.
Okay.
My today's presentation will be devoted to the role of information and the voters' interaction in manipulation problems. So how these two aspects influence manipulability. And as you know, one of the problems with collective decision making and one of the most popular research questions in social choice theory is how different rules allow for manipulation and which extent they allow for manipulation. Manipulation is the possibility of insincere voters' behavior when they try to be strategic and to misrepresent their preferences in order to achieve more preferable voting results. And so that's the question. And as we know, the founder of axiomatic approach in social choice, Kenneth Arrow, proved that some set of properties which may be which are needed for social choice rules can be incompatible. So following this axiomatic approach, Gibbert and Satterthwaite stated that every non-dictatorial social choice rule with at least 3 possible alternatives is vulnerable to individual manipulations. And now we know that not only individual manipulations, but also coalitional manipulations, so manipulations by groups of voters and under different assumptions about their preferences. All these frameworks allow for manipulations of manipulations in voting. But these studies normally they consider standard manipulation model, which assumes that voters think about possible manipulations individually, not taking into account other voters' actions and having complete information about other voters' preferences. So now it is of interest to know whether manipulations still hold and to which extent they are to which extent they influence social choice rules. When we drop these assumptions and add assumptions about incomplete information and different assumptions of voters' reasoning about other voters' actions. And besides, we would like to move from axiomatic studies to statistical investigation to reveal not just the facts of manipulability of some rule, but to find out to which extent these rules are vulnerable to manipulations or not. And the models of reasoning, of voters' reasoning, may be different, and I will briefly tell you about them. So basic model with non-strategic voters. Voters can be non-strategic, so they always vote sincerely. GS manipulators or Gibbard-Satterthwaite manipulators, they choose a strategy that allows to achieve a best result if other voters are non-strategic. So these are also called naive voters, naive manipulations. Then the concept of safe manipulation was suggested, and it is also individual manipulation, but these voters, when think about possible strategy, they take into account other voters' actions, but only voters of their own type. So they try to predict how voters of their type, or they are also called their coalition members, sometimes, how they vote. And this concept was suggested by Slinko and White, and by me and Hans Peters also. So voters try to think about their co-minded agents. Then, extending the concept of safe manipulation, voters try to think about other manipulators who also have an incentive to manipulate, but their own incentive, and not only of their type, but of other types also. Then extending this model to making it more and more complicated, so we can think about voters who think that other voters also can predict behavior of others, and so they can choose their best strategy according to their views of other voters, that they also can be strategic. So manipulators of kth level of rationality, they think that other voters are of level k-1. And models of cognitive hierarchy. A voter of kth level of cognitive hierarchy thinks that other voters can be of any level less than k. So all other voters, they constitute a mixture of different types of voters cognitive hierarchy, but they are always their levels are always less than k. So let's start with the standard model of manipulation, and we would like to consider it statistically, as I said, and to reveal the degree of manipulability. And this is the standard model. When voters think that others are non-strategic, and when they have complete information about every other voter preferences. So these are the share of manipulable profiles, preference profiles, in impartial culture model. So the share of manipulable profiles among m factorial power n preference profiles in total. So that's the case with 3 alternatives and the number of voters from 3 to 20. So we can see that this share of profiles, which allow for manipulations under these simple assumptions, are between these ratios, these shares are between 0.1 and 0.4, yeah, for all these rules. And we can compare these rules and their manipulability and their vulnerability to manipulation. We see that they are different, but the share of manipulable profiles may be quite high. So, but we don't know anything whether these figures still remain the same when we have incomplete information and other models of reasoning. So that's the question. And let's start with the model of incomplete information, how we consider incomplete information and how we view voters' incentives in this model. Let's consider an example with 5 voters having preferences P1, P2, P5, etc., P5, and 3 alternatives, A, B, and C. And they are ranked from the best at the top to the worst at the bottom. And let's suppose that plurality rule is used. So has voter 1 an incentive to misrepresent her preferences in this situation? In this situation, obviously not, because C is winner, and there is no other. There is no possibility for any other alternatives to win. But let's suppose that voter 1 doesn't know anything about other voters' preferences, but the winner of this rule after tie breaking. So he or she knows that the winner is C. And now we ask a question whether he or she has an incentive to misrepresent her preferences. So if public information is of this kind, it is C, then voter 1 thinks about the set of all preference profiles which are consistent with his or her knowledge. And this set of possible preference profiles is called an information set of this voter. Of course, he or she knows her own preferences and the voting result after tie breaking, and that's the set of possible preference profiles. If there is such an insincere preference order that in at least one possible situation, in at least one possible preference profile of this information set, such that in at least one possible situation, the voting result is better, and nothing changes in other possible situations, and there is no risk of getting a worse result, then this voter has an incentive to manipulate under given poll information function. So this strategy allows to achieve something and not being worse off. So this is an example of using a strategy BAC. What will be the result for this preference profile? Nothing will change. It's C, and in one possible preference profile, B will be the winner, and that makes for this voter, it creates a hope for him or her, and then this strategy is works for manipulation under incomplete information with this full information function. So BAC is a possible strategy, and this preference profile, original preference profile, where we had this voter under incomplete information, will be manipulable. So you see that under complete information, it was not manipulable, and with incomplete information, it is. Then we try to add some the aspect of other voters' actions. So now our voter thinks about his possible allies, his coalition members. These are the voters of the same type as a given voter. And in each possible preference profile, there is a set of his possible coalition members. So, for example, in this preference profile, he has an ally, and he has a coalition member in his group, and trying to predict their actions. He also computes the possible winner for every profile, and we see that if he thinks about actions of his coalition members, then this preference profile will also be manipulable. No, in this preference profile, the result will be better, and original preference profile will be also manipulable under an assumption of manipulation within a coalition. So manipulability, again, is the share of manipulable profiles, and we can then study the power of a coalition, how an assumption of thinking about their possible coalition members of voters, how can it influence the total manipulability of a rule. So for example, in this publication, we have a complete analysis of this aspect, power of a coalition. We compare different social choice rules and their vulnerability to manipulation, and we study the role of information available to voters. But here we also, our voters think about their coalition members, the voters of their own type. Now let's consider the concept of safe manipulation. If so, groups of voters, of course, can influence the voting results, have more opportunities to influence the voting result than single individuals, but they need to coordinate their actions. And in case communication between voters is restricted, it is natural to assume that voters can expect other like-minded people to act as they do, and that was the same as in the previous model when we considered coalitional manipulation under incomplete information. Now we would like to study whether they can do it safely, this group manipulation. So a voter, we assume that a voter has an incentive to manipulate within a coalition if there is such an insincere preference order that if all voters of this coalition use the same strategy for manipulation, they can achieve something better than the original result. So this is an example of profile which is manipulable within a coalition or within a group. And if the first three voters use the same strategy, which is marked by dark blue here, then they can achieve the winning of B, which is better for them than C. But if only a subset of the whole coalition manipulates, and the result can be worse than it was initially, then such kind of manipulation is considered as unsafe. And there is such an example. If only one voter manipulates, then the result is D, which is even worse for all these voters. So manipulation with this strategy is unsafe. And rules are considered as safely manipulable if there is a safely manipulable preference profile, and unsafely manipulable if there is an unsafely manipulable preference profile. And we are the most interesting cases are rules which are only safely manipulable. It means that there are no unsafely manipulable preference profiles. So this makes manipulation, group manipulation, more easier than if unsafe manipulation exists. And in the results of this study, we considered scoring rules, runoff procedure, STV and Copeland rule, and we found certain conditions for the number of voters and the number of alternatives which allow for unsafe manipulation. For example, plurality and veto rule are only safely manipulable. And for other rules, there is a threshold for the number of voters and alternatives for which manipulation is only safe, and after this threshold, manipulation can be unsafe. So these rules generally they are unsafely manipulable, but we need to know the number of voters and alternatives to know exactly. And the concept of safe manipulation was also considered by Slinko and White, as I already mentioned. And their models slightly differs from ours, and they assume that manipulation is successful or it exists if there is a right group of voters, of co-minded voters with identical preferences, which can achieve something better. So if the group is not right, It can be larger or smaller than it is needed for manipulation. And there is a risk of getting worse result in case the wrong group of manipulators participate in this action. Then this kind of manipulation is unsafe. So in our model, we assume that people just do not coordinate their actions at all, and they just think about what if all other people of my type also manipulate. And they assume that they need to coordinate their actions to choose the right set, and then it is okay, and then manipulation is successful. But if it is there is a miscommunication or miscoordination, then there can be a risk. And we found some relations with of our model with the model of Slinko and White. In the results on safe manipulation are presented in this publication. And if it is manipulable, if the rule is manipulable, then it is also
being recorded
in our model, and we proved it, and it is quite so safe manipulations are quite usual. So if manipulation in general exists, then safe manipulation also exists for any rule. And also we compared our model with Slinko and White. If a rule is safely or unsafely manipulable for some m and n, then it is also safely or unsafely manipulable according to Slinko and White. But another direction doesn't hold. Now we would like to go further, and we would like to reveal the degree of manipulability for rules when we have assumption of incomplete information and assumption of uncertainty about other voters' actions. So we would like to know whether the combination of these two types of uncertainty, how it influences manipulability, whether it reduces the number of manipulable preference profiles. So now voters think not only about agents of their own type, but about voters of other types.
This meeting is being recorded.
And in the working paper of with Daniel Karabikan, we considered and compared three models of voters' reasoning, of voters' expectations about other voters' actions. So model 1, which is a basic model with naive behavior under incomplete information. Model 2, when every voter takes into account that other voters who have an incentive to manipulate will also manipulate. And model 3, every voter takes into account that other voters may which have an incentive to manipulate may use their manipulation strategy or not. So there is an even higher level of uncertainty. So we computed the probability of manipulation for 3 alternatives and the number of voters from 3 to 20. We compared 12 social choice rules and 4 types of public information and 3 models of voters' behavior. So we showed that in combination with uncertainty, about other voters' action. Decreasing informativeness decreases manipulability. So if we consider only incomplete information, then the probability of manipulation may be high enough. And the reason for that was demonstrated earlier when I showed you a preference profile, which was not manipulable under complete information. And when we had incomplete information, it became manipulable with information about the unique winner. It was manipulable. And we have an increase in manipulability when we have only incomplete information. But when we add uncertainty about other voters' actions, then decreasing informativeness decreases manipulability. And that's quite logical. And we showed how theoretically showed how zero probability of manipulation is inherited between models and for different types of public information with a fixed model of reasoning. And we proved that for model 2 and for any given number of alternatives, for any scoring rule, the probability of manipulation becomes 0 when the number of voters exceeds a certain value. And that's presented in theorem 1 of this working paper. So for any scoring rule, we have such number of voters that for any bigger number of voters, the probability of manipulation is 0 for this scoring rule under an assumption of model 2. And also the proposition which states that if we have two pole information functions and P prime is at least as informative as P double prime, so P double prime is less informative, possibly less informative, then if we have 0 manipulability for some fixed model under P prime information function, then under P double prime, this probability is also 0 under a given model of reasoning. And let's see what are the computational results. This is the probability of manipulation of manipulable preference profile when we have information about the set of winners, and we see that there are many zero probability cases. It means that the combination of this information of uncertainty caused by incomplete information of this type and uncertainty about other voters' actions, which means that we found a strategy for naive manipulation and we check whether this strategy holds whether it works when other voters also manipulate. All voters which have an incentive to manipulate, they will manipulate, whether this strategy holds. And we see that for veto rule, for example, a naive strategy of manipulation doesn't hold for any number of voters which is greater than 4. Well, we computed for just until 20, but we can suspect the same, expect the same behavior of probability and for any larger number of voters. And we can see that there are many zero cases for other rules. And this is the information of information about the unique voter, unique alternative after tie breaking. So we have information about one voter which was the winner, and we can see that there are even more zero cases, zero manipulability cases, and this means that in model 2 there is no preference profile where a voter has an incentive to manipulate under these two types of uncertainty. And in model 3, in this model, I will remind you about this. We assume that voters think that others can manipulate or not. So if any voter has an incentive to manipulate, so it can use his strategy or not. So even higher level of uncertainty, and if naive strategy holds, then in some case it is safe for manipulation. It is safe to use it. So we extend the notion of safe manipulation to a more general case. So every other voter that has an incentive to manipulate can use his strategy or not. And that's the difference between manipulability indices, the probability of manipulations between model 2 and model 3. So we can see that there is no difference between these models for a small number of voters, but then this difference for some rules it increases, and this is the probability of manipulable preference profile for model 3, and the information about unique winner after tie breaking for different rules. So you can see that purple zeros which are marked with purple, these are new comparing to model 2. So we can see that non-zero manipulability is still observed for Copeland rule. So this means that naive strategy doesn't work for these rules under the combination of these two types of uncertainty. So, and now let's formulate models 2 and 3 in terms of cognitive hierarchy models. So in terms of model of K level of rationality, manipulation in model 2 means that does a naive strategy work for a voter which is of second level of rationality under incomplete information, under Paul information function pi. So does naive strategy work for level 2 voter? And manipulation in model 3 is the same as does a naive strategy work for level 2 voter of cognitive hierarchy model under a given Paul information function. So we don't know about any studies of manipulability of voting rules for different voters of this cognitive hierarchy models under incomplete information. And this would be an interesting question to answer. Does there exist any strategy for level 2 cognitive hierarchy voters, or even for voters of a higher level of cognitive hierarchy? And we can answer this question. And these are the probability of manipulation for level 2 cognitive hierarchy voters under one winner poll information function. So we can compare these values with values computed for model 3. Here we checked whether naive strategy works. And here we find the probability whether any strategy exists for level 2 cognitive hierarchy voters. So if naive strategy doesn't work, there may exist another strategy which allows to manipulate for level 2 cognitive hierarchy voter. And we can see that these probabilities, if they are not zero, they are slightly higher than these values. So this means that the main role in manipulation of level 2 cognitive hierarchy voters is the main role in manipulation is belongs to naive strategy, and that's the most the main strategy which can be used. But still there exist other strategies also. For example, for Copeland rule, we can see no zeros in this line. This means that there are other strategies which allow to manipulate under Copeland rule for level 2 cognitive hierarchy voters. And then we can extend this study to higher levels of cognitive hierarchy voters and find the threshold, find exact values where this zero manipulability begins to appear. So conditions on the number of voters, the number of alternatives, the type of information, and for different rules where we can achieve this non-manipulability, in fact, but it will be more honest to call it not non-manipulability, but some extent of they are immune to manipulation under these circumstances. But still, we can prove that there is no reason for voters to manipulate if they have such kind of uncertainties present in this situation. So the main conclusion is that information available to voters and their view of other voters' behavior are the crucial aspects for individual manipulation, and we need to take it into account and not just figures that say that there is 1/3 of manipulable profiles, but we need to take into account other assumptions too, because manipulability is highly dependent on these assumptions. So thank you very much for for your attention. I will be happy to answer your questions. Sorry for such a quick review of the studies. I hope if you are interested, you can look at the publications which I mentioned.